underlying bad heart disease, or because we indeed put them on diltiazem, really still fast, and let's add some beta block on top of it, and what we do, we block the node down completely. Well, now we went too far on the other side. So what's going on here? It's not an EKG, right? It's a telestress.
Yeah.
It's kind of fast there, right?
Very.
And to the right, it looks reasonable, right? At least the last 2 beats here, right?
Is the VTAC?
But some people say, oh, this is VT, right?
SVT?
But if you go normal, this is a normal beat, yes?
Right. Oh.
Normal beat? Yes?
Looks like it's still.
Normal beat? Looks reminiscent?
So it's like equal. There.
Normal beat?
Yeah. Yep.
Possibly.
Yep. It's there.
So you cannot have normal beats plus VT at the same time.
Right.
So this is artifact.
Gotcha.
Yeah, I
Right?
did see
It's buried.
The QRS marches back into it.
Yeah.
It's if you would just have the lower tracing, it'd be incredibly hard to diagnose. Right? On the top, I hope I can tell you that the R wave marches through, and now you recognize it, right? So this is somebody in the bathroom
Brushing teeth.
or somebody playing with the electrode.
VTAC.
Yes.
I'm in VTAC.
Is that the green one?
And we didn't dig too much into it, but one other reason why the QRS is wide is because the QRS is the heart is being paced.
Okay.
In this case, actually, we have a defibrillator in
Lead
place,
pace, huh?
but it paces the heart. You see the lead going down to the ventricle. We have a spike
Up there.
in front of the QRS. The QRS is wide because we're activating the heart in a completely
Different.
non-physiologic site. That's where the electricity starts, and it spreads out this way. Normally, the electricity comes down the bundle branches, right, and gives you a narrow QRS. But because we don't engage the bundle branches here, the QRS and paced QRS is typically wide. Depending on where you pace the heart from, the QRS looks different. Makes sense, right? If I have a pacing lead up here, the electricity travels this way. If I have a pacing lead down here, the electricity travels this way. And we can actually deduce from the morphology of the QRS where the pacing lead is. The easier thing is we look at the X-ray, right? So why is that? Have you ever seen device X-rays? So this is relatively typical. We almost always put the thing in from the left side. Right? Why? You can see it's sort of a nice C-shaped curve to get the leads in. Every now and then we have to go to the right side for multiple reasons, and you can imagine there's a curve this way, coming down, and a curve this way. So you have to curve the lead twice to get in the right place. It's doable, it's a little bit more tricky, but nonetheless we do it on the left side. We have the generator. The generator has a battery and a bunch of microchips. Pacemakers are more the size of a man's watch. This is a defibrillator. It's a bit larger. And then the leads go down. There's typically a lead to the atrium that's sort of hooked up like this, and one lead is going down to the ventricle. The reason why this is a defibrillator, you see this thing here? It's like a coil wrapped around the lead. And the defibrillator can shock the heart just like we do when you put your patches on by delivering a shock between the coil and the housing or the can of the generator. It's like there's a metal surface, right?
Oh,
So
yeah.
between the coil and the housing, the device
Delivers.
can shock the heart, and it's very effective. You need how much to shock VT or VF externally?
200 joules.
Right, 300 joules, or the biphase is 200. Inside the heart, we may need as little as 10 or 15 joules, so by the factor of 10 less. Why? Well, we're sitting right inside the chest and the heart, don't have to go through the chest wall.
You should not feel it, Dr. Hart, right?
The patient feels it.
But you will not feel it, right? If
You will feel the patient jerk when you touch it,
Gotcha.
but it's extremely unlikely unless you hug
Hugging.
the patient.
You shocked
that
too.
You get shocked.
Gotcha.
It's extremely unlikely.
You're
Right.
not feeling well.
All right, thank you.
All right.